Our speaker this evening has more than 10 years of experience, is an entrepreneur, and formerly co-founded Trip Films, the largest database of travel videos on the web. Please welcome the information engineer of Archway Health Advisors, Luc Pezet. Thank you. Good evening, everyone. Can you hear me in the back? Or do I need to speak louder?
Louder.
Louder? Is that enough?
Plus fort.
Nice, French people. Okay, so I'm going to share with you today some of the most recent Hadoop path experience with data mining and analytics. But first, what I want to give you some context on our experience. Back in 2010, we used Hadoop and Hive to process video logs. This is like Hadoop 101, processing web logs. And a couple years after that, we used Hadoop and Hive again to process student answers to assessments, to English and math tests for the Achievement Network, a nonprofit organization. And a couple years after that, actually a year or so ago, a friend of ours came to us and asked, "Do you know how to process data?" I said, "Yeah, we do." And then he asked us, "Do you know how to process a lot of data?" Of course, we know Hadoop, right? We know how to process data. Then he asked actually the most important question, which was, "Do you know how to process Medicare data, healthcare data?" And all confident that we were, we said, "Yes, of course." At the end of the day, data is just zeros and ones, right? Well, we were wrong. So let me give you, let me tell you a bit more about the Medicare data and actually the data, what it is exactly. Because this is really one important role in data mining, is you have to understand the data you're dealing with and its context. So there's this federal agency called the Centers for Medicare and Medicaid Services, or CMS for short. This agency manages a program called the Medicare program. Medicare is a national social insurance program that covers Americans age 65 and older, and it's been in place since 1966. Now, for almost 50 years, this program has been running under a fee-for-service model. Let me explain what that is. So let's say I'm a senior citizen, and I go and I need actually a hip replacement, a hip surgery. So I go to a hospital where care is going to be provided for me for like 3 days. That the doctor at the hospital is going to send like a bill to CMS, say, "Hey, I provided some service to one of your beneficiaries. Please pay me for that service, for those services." And here CMS is going to pay $3,000 for the doctors and the hospital. And then I'm going to get discharged to a skilled nursing facility, or SNF for short. And there I'm going to spend 18 days where care is going to be provided to me again. And they're going to send a claim or bill to CMS as well for all the care they provided. There's something might go wrong, and I might get readmitted to the hospital. There was some complication to my hip, and I get readmitted to the hospital. There again, they're going to send claims. And finally, I'm going to be sent back home, because someone's going to come and visit me and pay me like 12 visits to take care of it. So all in all here, the whole hip replacement episode of care costs about $24,000 for CMS. Now, we can see here that everything is very much in silo. There's little incentive for any of those settings to coordinate with everybody else. This type of payment rewards quantity of service over quality of service. So I don't know if you've been following what's going on in the government, especially in healthcare, but there's a campaign actually coming out, and it can be summarized in 3 words: better, smarter, healthier. Better care, smarter spending, and healthier people. And in that campaign, CMS 3 years ago, or less than that actually, came up with a new program called the Bundled Payment for Care Improvement, or BPCI. Under this initiative, organization will enter into payment arrangements that include financial and performance accountability for episodes of care. Hopefully, the goal is that those models will provide some incentives to care providers to provide better care. Let's listed some models here. So depending on where you sit in the episode, if you're a hospital, a SNF, an HHA, there will be some different models actually provided from CMS, different prices for your episode. So here's how it works. It's still business as usual. If I go to hospital, I need a hip replacement, I go to hospital, I provide care. The hospital and doctor are still going to send those claims to CMS. But CMS is going to say, for hip replacement, I'm going to pay you $20,000. Make everything you can to go below that threshold. And so they're going to do the best possible, take care of me. Then I get sent to SNF for 18 days, and then there's no complication. I get sent back home. Here, the SNF and the hospital, they spend $15,000, which means that they get to keep $5,000. So they can share $5,000. So we get a better care, smarter spending, and healthier as well, hopefully. Okay, let's talk about claims. So I mentioned a claim. What actually claim? A claim is a statement of services and costs from a healthcare provider, hospital, doctor, anyone. Patient information, it contains patient information, diagnosis information, procedure information. And as we saw, there are actually different types of claims. The claims that the hospital is going to send to CMS are different than the claims that the SNF are going to send, and so on. Now, if you look at an episode of care here, this is what it would look like with claims. Because the problem with this is that actually it's not like the DMV. I'm going to go get a ticket, and every time I go to a booth, I have the same ticket. Here, there's no ticket at all. Everything is inside on. We have to figure out that episode on those claims. So this is based on the same scenario that I mentioned earlier. We have over there 2 IP claims. That stands for inpatient claims, hospital. And here we can see that those 2 claims are actually overlapping each other. And there could be some rules on how to deal with that. And then for those 18 days I spent at the SNF sent actually 3 claims, not just 1, 3. We have to deal with that. Those are actually called interim claims. And then what we see here is just another IP claim. And there are going to be some rules to figure out whether this is a new episode or actually a readmission of the previous IP claims. Okay, so CMS provided some specifications on how to process the claims to figure out and detect episodes. So the way to go about it is to take all those claims and just put them in chronological order, like I did at the very top. And then there'll be some steps, depending on the model, there'll be some steps to go through to identify what we are interested in. The first step might be to flag every hospital stage. You can see that some actually IP are not hospital stage. Some hospitals are not part of the program, for example. And then for the same row set, we're going to flag all the post-acute care settings, which are SNFs, HHA, rehab, and so on. And here in green. Now from those post-acute care settings, claims, we're going to go back 30 days, trying to find what they call an anchor, what started the episode of care. It sounds simple, but like here, if we go 30 days from that HHA, for example, I'm going to jump onto that 2 actually anchor, 2 possible anchors. So here again, there'll be some rules on how to deal with that. And finally,
question. Sorry, what is the color coding here?
Well, that's just to differentiate between anchors and actually episode initiators. So this is to just do a SNF, HHA, this is hospital. And then we try to figure out the episode of care. This is actually a model for SNF. So if I'm a SNF and I try to participate in this program, everything would be based on what happened after the hospital. Like if all the money spent in HHA would actually impact me, for example. So as I said earlier, with no background in Hadoop, the first thing we try to do is implement those specifications using Hadoop and Pig. Pig is, those who don't know, is a data processing language, almost a de facto standard in Hadoop, right? But there are mainly actually shortcomings and problems with this platform, and I'm just going to mention a couple here. The first one is that it's not a very good feature, but it's a procedural language, which means that every statement I write will be translated into one or more MapReduce jobs. And that means that the optimization of the flow of the process is entirely up to me, which is very different, for example, from SQL, where actually there would be an execution plan based on my query and the data that there is. Also, Pig is a very much a relational-oriented language. So it doesn't really go at the record level, which we may want to do, which we want to do for those claim data, for example. There are two other points in Pig, and one, this is actually from last year. There's been actually 3 or 4 releases from that time. So I'm not sure where it stands now. But at the time, it was not possible to specify inline data. So every time you wanted to do some experimentation, or you wanted to test the language, you would have to upload a file to the cluster before being able to use it in your scripts. The second thing is, it was impossible at the time to specify and to code and to run unit tests within Pig. So what we started to list actually all the features that we want the solution to have to be able to help us with that project. We wanted, at the end, we realized we want something that is that gives us a lot of productivity actually for that task. Something that is very flushed out from data mining to actually providing the data to our clients. So the first solution we looked into is an obvious one for the industry is SaaS. SaaS is a very successful business analytics and BI software company. It's the de facto standard in the healthcare industry. If you go on CMS website, get any documentation or try to get any data from it, you'll always have some snippet of code from SaaS to load that data into your system. The problem with SaaS is twofold. The first is proprietary, with actually a pretty steep price. And the second is they also provide services to the healthcare industry, which made them actually a competitor to us. So we kept on looking, and that's when we stumbled upon this amazing technology called HPC Systems. And I'm going to let Rodrigo Pastrana, consulting software engineer at LexisNexis, introduce that to you.
Sounds good. Thank you. All right, can you guys in the back hear me?
Yes.
Okay, sounds good. So first of all, I want to thank Luc for giving us this opportunity to talk about HPC Systems. As he mentioned, my name is Rodrigo Pastrana. I'm a software developer with LexisNexis, and I have been working on the HPC Systems platform for the last 3 years or so. So I don't want to give away the Luc's secret, but Archway, I think, picked HPC Systems. And I'm going to let him talk about why he chose HPC Systems and how he's using the platform. I want to talk about what HPC Systems is. So first of all, high-performing computing cluster, for short, is a open source distributed data-intensive computing platform. So it's an end-to-end big data solution. It is open source. We joined the open source community about 4 years ago, but the technology itself has been around for about 10 to 12 years, something like that. And it was originally developed by LexisNexis and has been the driving force for the LexisNexis Risk division, which is a multi-billion-dollar a year company. So it's been in the critical path, and it is has been performing well for over a decade. So this is a very high-level diagram of the platform. What I want to point out here is 3 of the major components, being Thor, which we talked about earlier, but Thor is the data refinery component. This is where you do your ETL. And Roxy. Roxy is our fast data delivery component. And then what ties it all together is the very powerful language ECL. There's a lot of other components and very useful tools that we provide as part of the open source solution. but for this purpose, I'm just going to talk about these main three. So again, Thor. This is where this is what we call the big hammer, where you take your data and you do your cleansing, you do your transforming, you create your indices, and it is all programmable using this ECL language. Roxy is your published queries. This is how you deliver your data, and again, those algorithms are written in ECL as well. ECL language, I don't know why it cut off there, but ECL language is a very powerful language that we talked about. It's a declarative language, which is it's designed to work on big data and large-scale projects. One of the best benefits of the language is the very sophisticated compiler that it provides, which optimizes your statements, so you don't have to worry about the algorithms as much as you do in other languages. So we talked about it being a declarative programming language. This is what separates ECL from a lot of the other languages, in that it lets you, the developer, state what you want to do rather than stating how to do what it is that you want to accomplish. It provides very high level but intuitive data instructions, such as the transforms, projects, sorts, distributes, and so on and so forth. There's a lot of other great bullet points that describe the language. One of the newer ones that I like to talk about is the fact that it's polyglottic. That's a term that I came up with for this language, for this feature. And what that means is that it knows a lot of other languages. It supports embedding high-level languages such as Java, Python, R, SQL, and others into your ECL, which can be convenient if you have your algorithm already written in one of these other languages, but you insist on having it be part of your ECL algorithm. So that's the language, that's the platform. I want to talk about HPCsystems.com. That's our portal. It provides a lot of resources, including our distributions, but also it has a lot of tutorials. It has formal documentation for just about all of our components and our tools. It also includes a pre-configured VM image that makes it easy for kicking the tires. So you can just download this image, put it on your VM player, and have a single node distributed system that you can try out. So you can immediately, within I'd say a few minutes, have a system ready that you can program against. Currently, we are on version 5.2. It's our latest release. It added a lot of new features and improvements. We have a dashboard with a lot of web services in the background. That UI has been drastically improved. We have also added Ganglia and Nagios for system monitoring and for reporting or alerting. And we've always been very conscious of security. So we've added some security enhancements. We've added some new embedded languages, Cassandra, Memcache, and Redis. So not only can you embed your algorithm, you can also access different data stores within ECL. So foreign data stores outside of HPCC. We've added more JSON support. We already have some JSON support, but we've added more JSON data support. We've added a feature called Dynamic ESDL, which allows you to easily create a web service on top of your queries, so that you can provide a front end or a middleware end for your data delivery. And we've also added this project called Java API, which is a Java library which allows Java developers to easily interact with HPCC and a lot of the web services that we provide. So again, on HPCsystems.com, we provide a lot of resources, a lot of documentation, tutorials, classes, forums, and so on and so forth. So check it out. And with that, I'll turn it back over to Luke.
Thanks, Rodrigo.
I have a question here. I see this HPCC now, and I just curious. I am, by the way, I am the big data consultant.
Okay.
I go to the clients and work with them. So what I'm thinking right now is when we have Hadoop, we have Spark. Why we need HPCC? I was actually waiting for a slide which compares your HPCC with Spark.
Right, I don't have that here. On the HPCC website, HPCC Systems, we actually have a very thorough comparison between us and Hadoop. So what I would say is that our platform is end-to-end. It actually has everything you could need for a solution, whereas Hadoop tends to be, from our point of view, a small subset of what we provide. Also, one of the factors that distinguish us from Hadoop, I believe, is the language. The ECL language is very powerful, and it does a lot of the tasks that the developer has to do with targeting Hadoop. That's one major difference.
I would not compare it with Hadoop, but with Spark, because when I see the feature you mentioned, they are more close to Spark.
Okay.
Than the
so which feature are you talking about?
You know, when you say distributed, data distributed and low latency and all those features that you mentioned in previous slide.
So is Spark more of the data?
It's yeah. So I would compare Spark to actually Roxy because everything is in memory in Spark, right?
Okay, so it's
Roxy is really the thing that actually everything's going to be in memory, which is the other Thor, for example, is more to compare with like Pig, the processing languages. Even the platform actually provides some optimization with the graph actually. And when you run an ECL code, the execution is actually a graph, which is now Apache TZ, I believe. TZ, yeah. So Hive and Pig actually is going to be built on top of TZ, and the platform is already built on something actually similar. So if you think about all the ecosystem from Hadoop and Hadoop itself, well, the HPC system kind of grouped them all together a long time ago, and now building away from that as well. Does that?
Yeah. Thank you.
And you do have a connector for Hadoop.
And we also, yeah. So if you have your data in a Hadoop system, we do have, we offer various connectors to different data stores, one of them being a Hadoop connector, which allows you to stream your data back, well, hopefully one way towards HPCC, not back out to the Hadoop, but we do support the data going back out. So that's just one of many tools that support the platform that I didn't mention, but in the portal there, there's a lot of information about it. So in that sense, Spark, I think it's just one component, like you mentioned, Roxy, whereas we provide the whole gamut for the solution.
Do you see a need for statistical modeling workbench, some kind of facility for people who want to consider statistical modeling? Because you compare it to SAS and other things. What kind of facilities do you have for that?
The platform will provide actually some built-in modules actually for statistical analysis, but also for machine learning, like classifications and things like that. There's a lot. You can go to the portal and actually check all those white papers. They also actually do a comparison between Pig and ECL, for example, and as well other things. So some of those questions are actually already answered in the portal if you want to. Question right there?
So you mentioned that it's an open source project.
Can you speak louder, please?
Read-only open source project, or you can actually contribute to
No, yeah, we're actually encouraging the community at large to contribute back to the platform.
It's on GitHub. I couldn't find it. I went to the website.
Oh yeah, so the source is on GitHub,
Okay.
on their HPCC systems.
This is a question for both of you. You started your talk by talking about the problem in Medicare data, and we're talking about HPC. Can you guys put these two together for us?
Yeah.
Yeah. It's not the end, right?
I know.
Yeah,
in terms of like how you solve problems and so on.
Yeah. So I'm going to talk about that afterwards.
Okay.
Yep.
So he was looking over the different platforms that he could solve the problem with. He talked about Hadoop, SAS, and now I talked about HPCC systems, and I think that's a good point for
Yeah, we can
to continue.
So I'm working in education. We have to deal with FERPA, and I'm sure it sounds very similar to an issue you have to deal with HIPAA. How do you guys get around actually getting access to the data with HIPAA? Because even like the smallest thing could reveal the identity to the person, and that would prevent, it's a big no-no, prevent you from getting access to the data.
Right. So there's a lot of things you can do actually, especially HIPAA-wise. There's a lot of procedure to go about it, and I can explain it a little bit at the end of the presentation.
Can we do both real-time analytics and offline analytics like SAS?
So I haven't tried that. I believe it's possible actually with a Cassandra plugin, which actually you could actually store something maybe in Cassandra, maybe read from it from Roxy. I haven't done it yet. But so the real-time analytics would actually be this way, and the offline would be like if you have more major processing, you would go to the store and then export it to Roxy or something like with some delay.
I was just looking on something on your website.
Yeah.
Regarding risk management, what way do you manage risk for, let's say, your clients if they're primary care physicians, hospitals, etc.? How do you?
So that's more on the LexisNexis side of the business. That's one of the division of LexisNexis that created this platform. Here we're just talking about the platform, the technology used to process data. If we want to talk about LexisNexis risk, there's a whole business and a whole set of algorithms that the company employs to provide risk mitigation.
Okay, so you're not a broker,
Not today. It's outside of the scope of what we're talking about here. But to find more information about that, I would actually direct you to the LexisNexis.com/risk. Okay, so the HPC Systems.com is about the technology, the open source technology. Do you want to take questions
Just one
afterwards?
More. One more? Yeah. What's the limit of your platform in order term? Which kind of statistical analysis we can do? And which order we cannot do using the system?
What would you have in mind? Like any
What's the
specific?
limit? Can we do any kind of analysis on this system?
Pretty much anything I can think of, but maybe you can think of some more things. So I don't know. Pretty much, yeah. So if there is something that is not provided by the platform, the cool thing about it is that it's extensible. So if you need something that is in C++, where you have an algorithm or your own classification algorithm, for example, it's not provided by the platform, you can plug it in. It will actually be compiling, spread into the cluster, and just be run like the rest of the code in the system. Does that answer your question? Okay.
Thanks, Luke.
So thank you, Rodrigo. So we found that new technology, and we have to use it actually for data mining. So the first thing we're going to do is data mining, and for that we're going to use Thor. I'm not going to repeat what Rodrigo said, but remember that Thor is optimized for extraction, transformation, loading, sorting, and linking data, processing data. But it's a single-threaded actually cluster, just like MySQL. And to interact with it, we have to use ECL. So once again, I'm not going to repeat what Rodrigo said, but I'm going to compare it to what I said earlier about pig. So first thing is, ECL is a declarative language. And as Rodrigo said, I just have to code only what I need to do, and let the system figure out the best way to do it. Second point is that it's more data-centric. We'll see in a few slides that actually I can process a pair of records at a time, which is not possible with pig. It's also fast and implicitly parallel. Well, first is, this is C, C++, right? I'm not going to compare Java and C and C++. But it also has a compiler behind it. So any of the compilation theory they can think of, any of the constant folding or dead code removal, and all that stuff like that, you can actually do it in there. It's also implicitly parallel. So if I were to compare CL and SQL, they have the same concept. But with ECL, when something can run in parallel, it's going to do it. The two last point is something what I think is actually a necessary evil, especially when you do data mining, is you want to do some experimentation. You have some algorithm, you're not sure if it's going to work. You want to experiment. And so when you want to experiment, you don't want to worry about loading data or tweaking the data. I don't need the data. Forgot that field. I have to do it again. Here you can do it in line. And data mining also at some point get to a size or level that you want to make sure that every step of the way is actually doing it right. So ECL provide unit tests. We can code unit tests in ECL and run it right with the ECL. Okay. Here I'm going to show a little bit of, I'm going to compare ECL to SQL just in the syntax. At the very top, we have a group by in SQL where we select die group code, one dimension, one field, and we do some aggregation, volume and cost. We get the table in patient claims, and we group by that field dia group code. So then in ECL, we use that action called table. And here we specify exactly the same thing. The data set, this is not a table, it's called a data set now, inpatient claims. We specify the output, the structure of the output, where we have a dimension and two measures. And we say we want to group by on dia group code. So very similar. At the bottom, we have a simple join between two tables in SQL, and here between two data sets, once again, in ECL. And we just have those keywords left, which represent the first data set, and right, the second data set, and we provide the condition of the join. So I don't know about you, but I've done my fair share of SQL programming, and the least I use cursors in SQL, the better off I was, because it's so error prone actually, and so tricky to use. Now ECL provides two actions where actually we can go over records, and once again, it's not just going to go over one record after another. You could actually do that in parallel. So we use the iterate action, and we specify inpatient claims being the data set, and this is called a transform, which is a function that we're going to apply to our records. Here we're just setting a eavesdrop field to by using some statement here, some conditions on the function based on some dates on the claims. Okay, the last one I want to talk about is something that actually we ended up using a lot for that project, and that was sorely missing in other data processing languages, which is a rollup. The concept of the rollup is to merge records into one if they satisfy a condition. So here we have the signature of the rollup function, the first parameter of the data set, then the condition that's going to apply to a left record and a right record. So we're going to order the records, and we're going to look at them by pair. We're going to have a left record and a right record. And when the records satisfy the condition, we're going to apply the transformation function. So here's an example. We have a data set of 6 records here. And we're going to first look at R1 and R2. And if they satisfy the condition, what they do here, we're going to create a new record, RA. Now, the trick here is that instead of looking at R2 and R3 for the next pair, it's going to look at RA and R3 now. And if they match again, we're going to create another record, RB. So we're going to end up here with 4 records, RB, R4, R5, and R6. Doing something like this in other languages, like it's actually something very tedious and something very error-prone. Okay, so now that you're all ECL masters, this is specification from CMS, which we're going to try to solve here. So the intent here is to make the series of interim claims look like a single claim. So if you remember from earlier, we have those sniff claims. We have 3 sniff claims in the cascade, right? What we're going to try to do is try to make actually just one claim. They just look like one claim. The admission date of the first claim is going to be the admission date of the single claim, and the discharge date of the last claim is going to be the discharge date of the whole claim. So this is easy in SQL. It's just the mean of the admission date and the max of the admission date. Easy, right? Now I'm going to skip number 2. Not interesting. Number 3. The MS-DRG, it's just a bit of information, which is the diagnosis code. So I came here for a key replacement. That's what he's going to see on the claims. The MS-DRG from the last claim of the single stay is actually important to us. We're going to have to keep it. This is not the mean, this is not the max. We have to keep the last one from the series. Number 4, the cost across all IP claims, we're going to aggregate them. That's just a sum, that's easy. And number 5, claims where the last in the series claims has patient as still patient. So I might be still, at the end of the episode, we're going to look at the episode in the window, in 30, 60, or 90 days. And maybe at those 90 days, I'm still at the sniff, actually. I'm still a patient there. So if that happens, then we're going to flag them and actually drop them. So here again, we need to keep that flag, that information from the last claim. It's not the min, it's not the max. So here's a solution in ECL. Actually, the solution is the first 4 lines of code. We're going to first sort the data set by some keys that we're going to use in the rollup. A BNASK is just a BNA ID, beneficiary ID, provider, admission date, discharge date, and so on. And then I'm going to call the rollup on that data set that's been sorted. So distributed on my cluster. And I'm going to use two clauses here. Is interim, which is going to return true if the two actually are interim claims. And when they do, when they satisfy that function, I'm just going to call merge interim claims here. So we can see here that, contrary to SQL, it's very much like Pig, which actually it's very readable code and very data pipeline oriented. Now, at the bottom, what we're doing is kind of a best practice in data mining. When you come up with a model and you run results through it, data through it, and you get some results, and then you're going to get an expert to look at the results, and which usually they come back with comments like, well, how's that why is that number so low? Where's that data? Why is it missing? And so one thing to do is actually, instead of filtering out the data, it's actually to flag it, to keep it and flag it. And that's what we're doing actually at the very bottom. And you can see here is very readable code. We join on what was before the rollup and after the rollup. And we keep with the write only, like a very common join in any relational language. We keep only what was before, and it's no longer in the results. And we do a project, which was one of those things that we saw earlier, the iterate, the same thing. And we're going to set the flag as is dropped true, and we're going to give a reason why it was dropped.
So the question, the rollup, right? You're looking at a large data set here, right? Mm-hmm. And the rollup is going to roll up at a patient level, at the episode per patient. You know, several episodes getting combined into one.
Claims,
right?
yes. So claims, yeah. So the way you have to see it is you distribute the data in your cluster, right? Against some keys, with some keys on it, right? So there's almost like a hash for it. And when I do the rollup, actually in my condition, I'm going to use the same keys, which means that on every node, every single node of my cluster, the rollup is going to run locally in those nodes.
Right.
Make sense?
Okay, so you're rolling up the claims into one single representation per patient, right?
Correct. Yeah. For the same type of claims, yeah. Okay. Something that actually came up actually with data mining is when you get some data and you run your model against it, at some point you need to add some more data to validate your model. Right? The more data you have and the more you validate, the better your model is actually. But if it's not good, actually you can actually tweak it and find the discrepancies. If I were to do it in Pig, I would have to actually go outside of Pig and script something outside of Pig, which is very often the case actually with the Hive as well. Is I have to code in Java, so my produce job using my Hive or Pig scripts. The platform provides what's called a template language, which is a way to script ECL inside ECL. And the way it works is that it takes an XML as an input and generates an ECL code. So here the first statement, so I'm gonna create that new function that load all clean files. And the first statement here is load XML, which I pass as a parameter to that function. And it says for each folder tag, do the following. At the top, I'm just gonna extract stuff from the XML, but at the bottom is really the code that actually I'm gonna run. For each folder, I'm just gonna run an ETL job against it. And this is actually one way to call it, that function. A hard-coded XML with all my folders that I need to load to ETL, and I just call that function with that XML. There's something else from the platform that's available. Is actually we can actually make an HTTP call and get that XML from some other service. So I can actually schedule this to be run on a regular basis. Okay. So now what we're saying is, I went a little bit beyond data mining, and that's something that actually we didn't see much when we started this project, or foresee much of this specific project, is that there's some necessary evil that we need to provide into the platform to be productive. Some of those, I listed them here. The first is, like you said, for in our industry, is security and authentication, making sure everything is secure, and we can audit it. Collaboration, unit test, and visualization. So let me explain those a little bit.
We have a question.
Oh, yeah, right.
I'm sorry, I'm having a big disconnect here. So I'm a software developer. I work for Christos Health. We use Cerner in the acute system. Some hospitals use Medicare. Some other hospitals use, Epic. And then in the clinical side, we use ECW. So this data is everywhere, right? Today, we actually do transformation through SQL to Microsoft, the Microsoft product, the Microsoft services, SQL services. We do the transformation of data, and then we pull the data. However, we always rely on the actual vendors to provide that data. Every vendor has their own flavor of I guess, SQL. In the case of Cerner, they use CCL. But then you mentioned something about dropping the bill, or creating that charge fee based on those series of services across all these platforms. Are you guys replacing Affinity as the charging platform? So I just having really hard time. Is this a BI solution, or is this a charging solution? And how do you guys leverage these other vendors out there doing,
So here the source of the data, one point to see here is that the source of the data comes from CMS. So CMS receive all those claim data, and they already cleanse it. They already model it, and they have a schema for every single claim that they receive, right? And they provide that to us. So in a way, for this project, the only source is actually CMS. So there's only one source to actually integrate, to deal with, right? Now, for the service we do data mining, and I'll explain a little bit later, to provide some insights into their episodes of care. Because today, if you're in hospital, you don't know what's going on. Like after that sniff, you don't know what's going on to the HHN, to the home health agencies, what they're doing, how much they're billing, and things like that. And that's what we're providing to some of the customers, some of the participants of this program. I don't know if you know, but the Archway Health Advisors is a convener. It's an awarded convener. So we have some care providers and that actually run for this program, and we help them getting the data, getting the claim data, doing some performance analysis, and providing help with their care management as well.
So I submit, $300 million on reimbursements through Medicare, and then through the systems that my hospital uses, whether it's Cerner, whether it's ECW, whatever, and then you guys will provide me the data back from CMS, so I could compare it and actually see where my services are not getting the full benefit of each service.
Well, if you want to reintegrate with your system, you can do it. We can do it at Benari level, for example. We have the heat number, or we have a piece of information where you can actually link into your own claims, right? But the service we're providing here is actually more like overview of how you're performing in that program, how much your episode actually costs under that program, and not under on your own ongoing operations in a way. Does that make sense?
Yeah, I guess. Well, yeah.
So is this about, just kind of extending that question, is this about validating if somebody is complying with the bundle payment, if you said 20,000 and the actual cost was 24,000, so you're trying to ask them to keep it under 20,000. This is validating whether that happened or not. Is that
correct? So there's two, right. So this project only is about past performance. So we already have the claim data, which means the service already being provided, right? Yes. And we just go through it, and we just make sure that everything is on track with what they signed up for with CMS.
And now you're also saying there's some predictive analytics capabilities that you're going to talk about.
Right, which is not really part actually of this session. This is more from the past data, because one of the primary care providers is that they have operation, they have something going on, and they're very focused on what they're doing today, and not much of what others are doing. They do a little bit, but not to only to some extent. And here they're coming with that program which says, I'm going to say when you get a patient that has a hip replacement, the episode is going to be $20,000. You know exactly your operations. You know how much you cost. You know how much you bill CMS from your side, but you don't know from the rest of the people. So you need to have some insight into what's going on after.
So
Maybe just
are you
benchmarking.
are you using all the past data that you're getting from CMS to help CMS establish those benchmarks, whether it should be 20,000? Is that what they're doing with this data that you are organizing for them?
So there's two sides. One is the CMS side that's going to run that program, right? They're going to take the data themselves and they're going to figure out the price for each setting. For your hospital, the hip replacement is going to be $20,000. For yours, it's going to be maybe 18, and for someone else, it's going to be a different price because it's based on performance. What we provide is more like we can do it on a faster basis. For example, CMS is going to do it on a quarterly basis, and I can do it on a monthly basis. That's one service. Another one is I can do some benchmarking. I can actually use CMS provide a lot of data sets, and they provide something called the limited data set, which is all the claims, almost all of them, for nationwide. So actually get that, run through that engine to actually detect episodes and run some benchmarking. And do benchmarking in the same county or in the same state, for example. And then, so one part of this program was also to figure out, am I going to participate in this program? Is that really worth it? Am I going to make any money out of it, right?
Okay.
So one was called the bundle selection analysis. So when you want to say, I want to apply to hip replacement because I see everybody else is not doing it right, and I'm doing it right, and I'm going to make some money out of it. So that's another service.
So that's
Make sense?
yes.
What kind of scale is this project? Like say, what's the data set, the size, or how many years of history, or is it the whole country, the data from the whole country, or no? Give us an overview of the size of the project.
Sure. So for benchmarking, for example, we got almost 100% of the claim data, almost, because there are two type of claims that the CMS doesn't want to provide at 100%, they provide only at 5%, so we have only a sample of it. And this is, we have, I think, 2 or 3 years worth of data, and I don't remember the numbers, but it's in 100 of gigabyte, for example, that we process through each year.
On each.
Yeah. So, and then when you go at the hospital level, right, the care provider level, then it's much smaller than that. And this could be from 100 megabytes to a couple gigabytes. It depends. It really depends on how much actual information you have.
And this is just a small portion of the Medicare program, right? This is
Exactly.
a
Yeah. So
bundled pay,
Medicare is a big program that covers all the Americans, right? And then there's a small initiative that is the BPCI program. Now, the goal, I don't know if you saw it here, but at the beginning I provided an example where there was like $24,000 worth of expenditure from CMS for just my hip replacement. This is not something actually very crazy. It's actually, it could be about right. Now, CMS is trying to cut down expenditure for all those episodes of care. So we don't know yet. I don't work for CMS, but it's very likely actually that the fee-for-service model is going to be replaced by the BPCI model. So it just started 3 years ago. There was for 1 year only some people testing that program, and we are in the program now is in a full year since like a month or two ago. Does that answer the question?
And what kind of resources do you need to deploy for? Let's say like a cluster of computers, or like what kind of scale process?
So we don't really have. I mean, everything is pretty slow, so we don't need to have real time kind of insight into the thing. So we have a small cluster of I'd say 10 nodes, and we can process, for example, a full year to do benchmarking in under an hour.
Can I ask everyone to just hold questions? We're going to have an actual QA session somewhere around 5 to 10 minutes from now, but let's just make sure to keep them on track to get through the presentation. So please hold questions just until QA. A few more minutes. Thank you.
I'm going to keep some of the slides now. So one thing that we didn't foresee actually at the very beginning is collaboration. So to understand how it works, first every time you submit an ECL code on the platform, it's going to create what's called a work unit. It's like a job in a way in Hadoop. What it's going to have is going to have its own identifier. It's going to have some attribution because we have authentication enabled here. So we know who's the owner, who actually executed that code. We also have some very important information. The query itself, the ECL code that got executed. Some timing information. So every step in the ECL code, we're going to know how long it took to execute that step, and the results. Which means that I can go into here. This is again provided by the platform as is. This is called the ECL watch, and one of the things I can get from that ECL watch site is the work units, everything I got run against the cluster. So if someone comes to me and say, I have a problem with one of my queries, can you take a look? He's going to send me the work unit ID. I'm going to look it up and pull out all the information, everything that happened for that query when it got run. Here we can see some of the tabs at the top. We can see some outputs, have 3 actually results, some timing information, and I mentioned the graph earlier. We can actually see the execution of the ECL code as a graph. And obviously we have the ECL code. So if someone comes to me and says, my query doesn't run, I can go here, go into the ECL tab, copy it, and run it locally, for example, to figure it out. So I don't have to look over the shoulder of anyone. They can actually just send me their working ID. This is one example of if someone actually say my query is running too slow, I can look into the timing information and figure out with the heat map or further down here what statement actually took the longest, and look into that. Okay, the last one I'm going to talk about beyond processing here is unit tests. As I said earlier, you come to a point where there's so many things going on with data mining that you want to make sure that everything runs the way it should be. Our BPCI engine, to did that episode, is about it's from 20 to 30,000 lines of code. It's not really a lot, but when you're dealing with data processing, there's a lot of things that can go wrong with those lines of code. Here I'm creating a module called the ATM claim, so I'm going to test and claims here, specifying some test data at the top, plugging into my algorithm, and at the bottom I provide a test suite which looks very much like JUnit for those who actually know. I provide some certain what should be dropped and what should not be dropped, and so on. This is something else with the data we're dealing with, that sometimes the data files we have, they are all easily over 250 fields. So what we don't want to do is specify 250 values when doing unit test. So what we do is, and what we can do with the platform is PCL, we can provide a simplified layout, just a smaller structure. We can use only the fields and the information that we need in our text. Here we have less than 10, I think. And on the right here, we have 2 ways actually to specify that test data. One is inline data set. At the very top, we'll specify just the value for each field in my structure. And at the bottom, something that maybe Ruby programmers will be very familiar with is called name parameters. I can call a function and just set the value to the name of the parameter. Okay, I'm going to skip that a bit. There's something else provided by the platform, which is actually visualization. When I went to that work unit page, one of the things I can see in the output tab is actually I can visualize some of the data that I generated. This is built into the platform, but what we really needed is trying to graph out the episodes with the claims that we had, right? So here we're saying 3 beneficiaries, one with actually 2 episodes, the one in the middle just 1, and the one at the bottom with actually 2 episodes. And we're graphing out like sniff claims here, for example. So we can, by looking at that, I know that in this episode in the middle, I can see that the sniff claims is going over my window. I know I'm going to have some proration here. And I can see that I have 3 overlapping sniff claims. I have to watch out for that. Okay, so now we have the platform, and HPC was great to actually be productive about not only data mining, but making sure everything runs smoothly and running the way it should be. Now we need to provide some insight into the results of our models and data mining. What we're looking at here is discrete representation of episode cost by rounding to the nearest $1,000, right? So what we have at the beginning is we can see that we have about 40 episodes that cost about $1,000. Now this actually doesn't give us much insight. This is much better. Here we're actually finding the constituent actually of the episode of cost by readmission. So a care provider can look at that and say, and devise a strategy to cut costs. One is to shift the whole curve to the left, or try to shave off those the green and the red area by reducing readmission in his practice. But this is right sitting on my desk on my laptop on the cluster. Now I need to make it accessible to my clients. So the usual approach here is actually to export it into a different cluster. If you come from Hive or from Pig, for example, you might go to a relational database, an OLAP database, a column database, or even another Hadoop cluster with Cloud Impala on top of it. Here we chose to actually go with Roxy for a couple of reasons. Rodrigo mentioned some of them already, and I'm going to get right to it. Is Roxy is a data warehouse on steroids, really, because it provides a way to create web services on top of it using ECL. And this is how it works. At the very top here, I specify my input parameters to my web service using this stored keyword, which means that I'm going to send a document with some of those parameters: offset, results, begin date, and end date. Easy. And then the core of my report here is going to be a cross-correlation report. I'm using the table keyword here, specifying some dimensions at the top and some of the aggregation, some of the measures at the bottom. And I'm going to call another function, another macro that actually going to take all this and create a web service. So when I compile and publish this code against the platform, it's going to do a lot of things. One is it's going to create an endpoint for me. Here we're looking at the JSON endpoint. It could be SOAP, but here's JSON. And we can see my summary service is right there in the endpoint. I'm passing my request, JSON request with some of the parameters we saw in the BCL code, and I'm getting the JSON response for it. The platform provides tools to actually test your newly created services with forms for one, with also some links to test to get a simple request, a simple response, the restore, and so on. Okay. One thing that usually comes to mind when it gets to delivering data to clients is how I'm going to update the data without disrupting my service. You see, the platform provides something called the superfiles. So when you call a data set, you actually can reference a superfile. Here I'm doing an example with weblogs. So if I have this logical find name, it's called logical find name here, I'm just going to create a superfile for it, but I'm going to use it in my report here. It's just a cross-tabulation report on IP addresses. While it's running, when it's being serving clients, I can, on another end of the program, start adding 1 day worth of data, for example, to that superfile. This allows us to, without changing any of the service or recompiling anything, to update the data that is used to, for delivery to the client. Okay, the last one last thing is, I've been using code implicitly I've been actually using a lot of code, and we didn't really see that. That's something that we cannot do with SQL. It's something we can do to some extent with P, but here you can see my service running that I mentioned earlier. And what it's going to do here basically is it's going to define a schema and a behavior, almost like a WSDL for my web service in ECL. In the green area here, I just say how the data is going to be filtered based on the parameters I pass to that function. And at the bottom, I'm going to actually specify the output of my web service. Here I'm going to have 3 outputs. The first one is going to be just a ping, an echo of the request with an intercheck. The second one is going to be metadata, where I'm going to put, for example, the total available results for that request. So we can go through pagination, for example. And the bottom one would be actually the actual output of my service, so the cross-tabulation that we saw earlier. Okay, so No, I've been talking about very like low level or ECL level. Now I want to go about like very high level and see actually how it integrates into an architecture, right? I want to show here that actually it doesn't really break any rules or any boundaries. It's very much a built-in replacement to anything you might actually already have. So to explain, to start with the question about the data and how actually we make sure that we have clean data, we do some of those filtering and it's called de-identification into the data acquisition layer. So when we get the data from a FTP server or external database, we might want to strip social security numbers, for example, or first name, last name, and so on. However, for this project, most of the time we need to keep the data as is because the data doesn't belong to us, it belongs to a client. They want to be able to access the data, we need to be able to provide the data as is. So here we have VPC with a role management actually for each of our VPC clusters in the data acquisition layers, and we store that on Amazon S3 being encrypted at rest as well. And then from that, we can actually load that data from our storage and do some mining using Thor. So we can use some test data for staging. In production, we can access directly actually our repository of claims. And then once we're done with Thor, we'll actually export that into Roxy, and Roxy is going to deliver into a web application. Okay. So that's pretty much what it is. Archway, as I said earlier, is actually a warning convener. We have some care providers working with us for that program, and we're helping them with care management. And when they sign up with us, they actually can go to a site and look at their performance today in this program, and everything is actually powered by HPC Systems. One last word is, we spent almost an hour here actually talking about HPC and what we can do with it. I've barely scratched the surface of actually the power of HPC in the platform. There's things like machine learning that we partially use, but not all of it, and knowledge extraction that's provided by the platform that go beyond actually what we're doing here. So I invite you to go to HPCsystems.com to check it out if you're interested. And thank you for your attention.
Thank you all, Luc Pezet. I want to remind you all that we are giving away a Kindle Fire HDX. You do have to be present to win. There is a bowl going around, but it was going around. Let's pass it around again. Pass it down to whoever wants. Throw your business card in there, or fill out the form that's in there. And someone in this room is going to win this Kindle Fire HDX right after Q&A. Also, I want to remind you, good questions do get $5 Starbucks gift cards. I only have a handful left. So let's start with you over there.
I was wondering, coming from a SQL background, even with ECL, there are certain things that are more, trying to optimize queries that in ECL, just the equivalent wouldn't be the same. So you're saying like a cursor runs in parallel in ECL, so you don't have to be as careful or worried about using them, or is there stuff in SQL, coming from SQL background, that you really don't have to worry about?
Right, so, well, there's a lot of things that come to mind, but so one thing is, when you go in SQL, actually, you might have, depending on the database you have, like if you have MySQL, it's all single-threaded, right? Now, if you come with ECL, if there's something that can run in parallel, it's going to be running parallel. So it's going to be more efficient right off the bat. That's one thing. Second thing is, coming from SQL, there's this graph. I don't have a slide here, but it's pretty much like the execution plane from SQL. So it gets to a point where it's very interesting because you can have the same code running either with development data, which is small data, or big data, and it's still going to be optimized by the system, which is different from PID, for example. Other thing is, so it's more, you can see that the way I wrote code is very much like PID, where you have a statement or a data pipeline on each line there. And it's more readable code and more data-centric than SQL is. SQL is more about structured language.
You had your hand up from before already.
Okay, so, so two questions. One is, do most of your customers use this data to decide if they're actually going to do bundle payments, and if so, what prices they're going to set, or are they already doing bundle payments and they're tracking performance against that?
Both. So when you join, there was a period actually, it's over, but there was a period where actually you have to decide whether or not you want to join the program. And if you join the program, you have to say, I want to do hip replacement, I want to do sepsis, I'm going to do all those kind of things from CMS. So you have to first analyze your data. CMS provides some of it, and we provide benchmark on top of it. And some other, but what we can do also is, I mentioned it, we have, the way the program works is by window. So if you say, I want to do a hip replacement bundle, you have to say whether you want to do a 30-day episode, a 60-day episode, a 90-day episode.
But are most of the provider groups already doing bundle payments, or are they trying to make a decision as to whether or not they want to?
Exactly. So that's one part. The first part is bundle selection.
Oh, okay.
Figuring out whether you're gonna go for it, and if you go for it, which one you're gonna choose,
Right.
and how. So the many flavors, and we help them with that. That's called bundle selection.
Okay, wait, we're gonna have one-on-one questions afterwards, so we have time for everybody. No, it's the lady.
Does it have something to do with outcomes analysis? Do you then analyze the outcome and see which is more effective and which is more productive, and then the government then helps doctors and groups choose which procedures to use?
So, I'm gonna sum that. So the government goes to only to a certain extent. So they just provide the data. They say you make your pick. And so what we do is we actually help them. First is reading the data, because what you get is really a spreadsheet of numbers. And you have different risk tracks. If you want to do like the 90% like risk, you want to take 90% of the 5% of the risk, you get 9% of the upside, and so on. So there's a lot of things that actually you need to understand about the data, which we do. That's one thing. Second thing is, so what we do is we can run some simulation. So we can say, if you choose this hip replacement for 30 days, here's what happens. If you choose for 60 days, here's what happens. And then we can talk about, okay, maybe it's worse for 60 days, but maybe it's easier to fix. So we can talk about outcomes and the choice, the selection they're going to make. So we do outcome analysis in a way, and also the selection.
So a quick question. We are an IT consulting company, and we work with a lot of healthcare industries and players in the healthcare industry. So on our point of view, we would like to understand, if we go out and recommend the particular solution to the client, what kind of support do we get from you to start ahead with our entire ecosystem building for them?
Okay, you're gonna have to repeat that, please.
Okay, so being an IT consulting company, we work with some of the healthcare industry and some other industries. So when we put our resources to start executing big data using your solution, what kind of support as an organization you would provide us, or the team would provide us in maybe implementing it as well?
So you're talking about Archway, or talking about HPC Systems?
HPC Systems.
Oh,
Let the doctor get it.
I don't know about that.
Wait, but quick by a show of hands, has anyone been to Dr. Villanustre's prior presentations with us more than a year ago? One guy, two, a few, okay, a few hands. Anyone remember what his background was before he started working as VP of Tax?
A neurosurgeon.
A neurosurgeon, that gets a $5 card. Yes, he's a brain surgeon, guys. That's a great question.
So it is brain surgeon. Thank you.
Yeah, are you able to answer the question?
Yeah, sure. Well, there are two aspects to this. One is the project is open source. All technology is available, and the community tends to be quite helpful if you just use the community vehicles. There are a number of distribution lists and forums and other things. And outside of the community support, if you do need enterprise support, we can provide that too. We understand that large companies sometimes require some sort of assurance on the responses and support and patching or whatever. So we offer commercially supported type of implementations as well. But if you don't want to pay anything, if you just want to use the free option, you can use the platform the same way. Everything's available, and the community, again, tends to be quite supportive.
Okay, we only have time for 2 more questions, and I am out of Starbucks cards, so don't take it personally if I don't give you one. Yes.
Yeah, I see that the components itself, the Tor, Roxy, they seem very usable. Can they use independently, or let me rephrase my question, can I integrate each component, individual component in my project, in my ecosystem? Is it possible?
Absolutely.
They're desired?
You can configure it any way you want. It's very flexible.
Okay. Last question of the evening? Yes.
It seems like you guys are very cost management oriented, but there's already programs like RedCap and Allscripts that exist. So why didn't you just build upon something like Microsoft Excel instead of creating a new language like ECL?
Did you say Microsoft Excel?
Yeah.
Well, it doesn't really scale that well, for one. But the other thing is, so we wanted to provide something that is that we can process actually even more data, and to be able to scale, to go from something very small. So what I said is, sometimes the SNF will come to us, and in the SNF and the HHA of the world, they might actually be a lot less volume, a lot less cost than the hospital, for example, the bigger hospitals, right? So they might actually have less data. They want to have the same solution, to provide the same solution, and use the same tools, whether it's small or big. So that was one aspect of it.
Do you see a lot of the care providers, like hospitals, are more interested in this, or you see smaller care providers are also coming to you with data?
Yeah, it's both. I'd say there's a lot more incentives for hospitals than there is actually for SNFs and everything. So when you participate, if you're a SNF, the episode might start before you. If the hospital already got that episode, you don't really get it. You're going to share the gains with the hospital, but it doesn't start with you. So there's a lot more actually incentives for hospital than for the rest of the spectrum.
Okay, Luc, Rodrigo, and Dr. Villanustre will all three be here for one-on-one questions afterwards. Feel free to come up and ask them. We're going to do the raffle now. Before we do the raffle, I want to give a great big round of applause. Thank you, Luc. Who's got the bucket for the giveaway?
Right here.
Right here. Thank you. Can I ask you just to mix it all up? Well, let's get the pen out of there. It's going to mess you up. I can't get the pen out. Okay. Okay. And can I ask you, look the other way, reach in, grab out a card. Just one. Okay. Now pick it up, read it.
Anasua Das.
Anasua Das? Is that you? Wait, take Thank you all for coming.
Thank you. I could never